Hello, everyone. My name's Beth, and for the past couple of years, I've been working at IBM in their Node.js team. And our team originally focused on bringing Node.js to IBM platforms, so like Power and Z. But since then, we've worked with the Node.js community to bring those platforms to be shipped there, and we help maintain them there. So now our drive internally is more about how we can encourage some of our enterprise customers to adopt more of the ecosystem. One of the key concerns that our customers are having is these dependencies. And because they're all open source, what risks come with that? So first of all, Node modules are great. So many of them are open source. There's over 800,000 to choose from. So if you want to do this small little project, chances are there's several modules you can pull in, and you can get going really quickly. And it promotes reuse and code sharing. So as an example, this is Node.js Twitter app. 14 lines of code, I can get a stream of tweets from NodeConf, which is great. And there's only one direct dependency. So 14 lines of code, one direct dependency, very terse, very quick. And it's good because I can concentrate on the actual business logic of my application and not the specific implementation details. But that's actually a lot of code that you're pushing to production. So from that one Twitter module, there's actually 49 modules in the tree and 46,000 lines of code. And that code is covered by 6 different licenses. So even though you thought, it's only 14 lines of code, and that code looks safe, so I'm just going to push it, you've actually got 46,000 lines of code at risk. And because you're deploying all of this, the risk is like exacerbated. And there's a few areas that come up quite regularly. So you've got security risk, licenses, maintenance, breaking changes, and compatibility. So taking a look at security, it's always a big topic in NPM and Node modules. Node Source and Screen actually did a survey last year of Node developers, and they found 84% were moderately to very confident in the security of Node core. So this means most people are happy to pick up the Node runtime. They're confident that when a security issue is detected, it will be fixed, you'll get a security release. So they're quite happy and confident to do that. But strangely, only 16% were confident that the third-party packages were vulnerability-free. So considering back to the previous slide, it was literally like less than 1% of the code was their own, and 99% of it was someone else's. If they're not confident in 99% of their code that it's vulnerability-free. And as you may have seen on Twitter, and so when there's a security in a Node module, it just escalates everywhere. And every year, we get a couple of notable ones pop up. So in 2017, we had a cross-env issue. So this was kind of a typosquatting vulnerability, where people would push malicious code to a very similar named package. So if you accidentally typed npm install Mr. Dash, you'd actually pick up this malicious code. And what this code actually did was it would, on install, it would ping all of your environment variables to a remote server. So you could have potentially just leaked credentials, et cetera, just from mistyping an npm install. So pretty scary. But because this happens quite a lot, this typosquatting, NPM and the community are getting really good at reporting and taking these things down as soon as possible. And then in 2018, we had the ESLint problem. I found this one quite interesting because it was actually targeting something you don't typically deploy because you normally use it as a dev dependency. And the way this attack happened is someone gained access of an ESLint publisher's account and then published a malicious release. And then everyone's CI and et cetera that's running ESLint, if they weren't hard-coding their specific version of ESLint, started picking it up. And what the malicious code did was it actually read the user's npm-rc file, or at least tried to. I think there were some bugs, so it just crashed. But it tried to read the npm-rc file, which stores your own npm tokens. So that creates like a viral attack, because once they just got one token, they could then leverage and get other people's and then do the same attack again and just spread it across the whole ecosystem. The solution was to revoke all npm tokens after a certain date. So it got fixed, but there is a few crazy minutes on Twitter where you saw everyone panicking. So to mitigate against security risk, there's a few things that you can do for free just to protect your back a little bit. The first is with npm 6, you get npm audit. So there you get a list of known vulnerabilities when you type npm audit. It also provides like a fix option so you can try and patch and upgrade to later versions. You've also got GitHub security alerts. So sometimes if you go to your GitHub package or app, it will actually say, oh, we found a vulnerability in here, and you can upgrade. And also locking down your package JSON and using a package lock. So if you had hard-coded your ESLint version to a very specific 4.1.1 or whatever it was, then you wouldn't have ever accidentally picked up that untrusted release. So various things you can do. There's also commercial services, etc. Then you've got licenses. So why should you care about licenses? Well, if you link with open source libraries and distribute the software, you actually need to be compliant with the license of those libraries. And that's not only the license of the modules. So in the Twitter example, that's not only the Twitter modules license. That's actually the 49 licenses in all of the other modules that you're pulling in. So it's only an issue if you're distributing the software, and sometimes it's a bit clouded by what the term distribute means. So transferring software between one employee to another at the same company, that's not normally a distribution. Users interacting with your app over the internet, that's not normally a distribution, but there are some network protective licenses to be aware of, because they do actually have rules around interacting with an app over a network. And hosting JavaScript files on a public web server is definitely a distribution. That is when you're distributing the software. And licenses kind of get grouped into three kind of areas. You have copyleft or protective. And with these licenses, if you include or link to these libraries, you have to license your application to the same level as the dependencies did. So if they were GPL, you'd have to license your app as GPL. You can't suddenly be more permissive or less permissive. And then you have weakly protective. So that's kind of the midway point where you've got less restriction if you're just linking to the libraries, but maybe a bit more restriction if you're actually bundling a library in and shipping it. And then you have public domain or permissive. These are like MIT, and they can allow you to do anything apart from sudo author. A lot of this legal speak is quite hard to understand, but luckily there's a few websites out there to help you. So you've got software licenses in plain English in tldrlegal.com, and chooselicense.com. That will help you click through and be like, I've created a new module, what should I license this as? And then GitHub's added a nice UI over the past couple of years. So if you click on a license file, you get a very simple breakdown of what you're allowed to do with that module or app. And then what licenses am I actually pulling in? So luckily, there's a Node module that can help you work out which licenses you're using in the whole tree. So it's just npx license-checker, and you can see the whole long list of what modules are in the whole tree. And I think you can give some options like exclude MIT and Apache 2, because if you know you're happy with those licenses, it will just show you the ones that are abnormal for your product or stack. And then looking at maintenance. So if 98% or 99% of your code isn't your own, it needs to be well maintained for your app to have a long life. So the kind of questions you should be asking is it a deprecated module? I was quite shocked, actually, when I looked through the top 100 NPM modules. You can actually click on some of them and say, this is actually deprecated. You think, oh, it's in the top 100, and it's actually deprecated. Are issues in the module being fixed? How active is the development? How many maintainers are there? So luckily, GitHub's built an Insights tab on a module on any repo. And it gives you information like number of commits in the last week, number of issues closed. So when I pick up a module, I often go have a look there and just try and gauge what's going on. Is it still active? Am I going to get any new features anytime soon? So that's GitHub Insights. But there's also NPM. NPM has got a search by quality filter. And this is built on top of npm-SIO. And npm-SIO was the output of some two developers hitting the same issues that our customers are seeing and being like, how maintained is this? How active is the development of this module, et cetera? And they actually created an analyzer that would look at the stats from GitHub and determine some metrics. So they would score everything out of 100%, and you get like 88% or 97%. It does some other checks as well, like has it got a license file? Are there any, and it also includes some known vulnerability stuff. So it's worth having a look. Find it quite interesting. The only thing is where it's, if you filter by it, you can get modules that are like getting 100%, but they're such small modules and such unknown, they've just managed to tick the right boxes to hit 100%. And then we have breaking changes. So some of the projects, especially with some of our customers, have still got relatively long release cycles. And if they were to choose a module that makes breaking changes every month, every 2 months or so, that just wouldn't work for them because they wouldn't have time to actually upgrade and ship a release in the time that they've created a new major of that module. So the first good thing to check is this module following semantic versioning? So semantic versioning is kind of a standard for versioning any application. The first digit is the major, and you only increment that when you make a breaking change. The second is for new features, and those features have to be backward compatible. If they're not backward compatible, it becomes a major. And then you have fix, and these are bug fixes that do not make breaking changes, so they have to be backward compatible too. So you should check, and the only thing is you need to check how strictly these modules are following Semver. There's no from what I've seen, there's no automated way that people are using to say this is a fix, this is a patch, this is a breaking change. So you kind of have to trust that they're applying it correctly. Again, how often am I updating major versions? So taking a look, if a module's been at version 4 for 5 years, then you know it's relatively sturdy, and if you're happy with that module in that state, then it's probably safe if you've got a long release cycle. And then there's our security and bug fixes only released on the latest major release. So this kind of looks towards Node, sorry. So with Node, you get a period of time for each LTS release where it's supported. So you get bug fixes and actually new features while it's inactive. But this doesn't apply to the module ecosystem. So many modules haven't adopted the kind of LTS policy that Node.js has. So if you were using a module on version 4, and then they release version 5, they might not backport security fixes to version 4. So then you're kind of tied because you have to either accept the breaking change or move up to version 5. Something we've been working on at IBM is to try and encourage modules to adopt long-term support plans. So we've got all of the IBM modules signed up to this. And what they actually agreed to do is say, we will support the major version of this module for the lifetime of a node release. So for example, one of our modules, Loopback, we will support version 3 for the lifetime of Node 8. And then when Node 8 goes out of support, Loopback 3 goes out of support. And this really helps our customers because they know they know when they need to upgrade by, and they also know that they can make the jump from Node 8 to 10 at the same time they make the jump from Loopback 3 to Loopback 4. So they've got something to plan to. And then we look at compatibility. So at IBM, we have lots of our own platforms, and the modules that are developed are normally developed on Linux, Mac, Windows. So for our customers, sometimes a module won't work on their platform, and they won't know about that until they actually deploy. So something we've been working on is a tool called Module Insights. And what this does is for a selection of modules, we pull in the module from GitHub, we run its own test suite, and then report back whether it's passed or failed. And we do this across major node versions, so Node 6, Node 8, and Node 10. And we do it across a variety of platforms. So we can direct our customers to the drop-down for Power, Linux on Power. And then they can see, oh, look, this module is green on Power, that's safe to pick. So it's really helping them decide which modules they can use. There is another use case as well. Because we have the columns with like Node 6 and Node 8, they can use this to look at it and be like, am I safe to move up to Node 8 on this module? Am I safe to move up to Node 10 on this module? Because if it's green all the way along on their platform, they're good to upgrade. And yeah, we're working on this. Anyone who has a module and wants to add it to the list can get added. We'll work with you. And we intend to expand it to collate as much data as possible. So kind of as a summary, like security is a big issue with NPM. There's 800,000 modules, so trying to mitigate against just one package pushing some malicious code is pretty big ask, especially with NPM and the community. But there are some things you can do and some tools that you can use to help protect yourself. And then licenses. So I actually didn't know I had to care about licenses until I started at IBM. And I built a tiny prototype, and the first thing my project manager asked me is, did you check the license? I was like, yeah, I checked it at the bottom level. And then they were like, did you check all of the licenses? I was like, oh, OK, I'll go do that. And then since then, I've been using NPX all the time. Maintenance, so you just have to gauge, like, go have a look, see what the module's like, see how active it is. Breaking changes, you're kind of sometimes in a catch-22, but hopefully if we can encourage more of the LTS, we can make it better for at least enterprise users to have a nice time frame of when they need to upgrade a certain module dependency. And also compatibility. So we want people to know if their module is working on our platforms as well. So we want to help module maintainers bring their modules to our platform. So thanks, everyone. I hope I've given you at least some tools or some information about things maybe you should care about when choosing your modules. And you can come see us at the IBM booth to talk about the module insights or the work we're doing with module LTS. And also, we have a drone raffle with our horse race game at 3:45, so feel free to come. And thank you. Thanks, everyone.